Okay, so today we're going to be reviewing, and then Monday is test number 3, and then we have more stuff, of course, and then test number 4. Now, I don't know how this works, but it just happens this way. Doesn't matter how many times I say it, somebody doesn't believe me, and then they ask the question again. So test number 4 is not a comprehensive final. It just covers the last unit. But there's no reason to really be happy about that because it's really confusing and hard. So it's a very difficult test. A lot of people don't do well on it. And it takes a lot of work to be able to understand what's going on. But it's not a comprehensive final. All right. So that will happen when we get there on August the 15th, which after all is less than a month away. So the exam number 3 is coming up on Monday. Now, with regards to that, when we look at the resources section of Blackboard, we click on notes. What you will see is the practice for test number 3, which we'll talk about here in a few minutes. But there's also a new thing that I just put up yesterday, I believe, and that is formulas for test number 3. Okay, this has recently been revised because it's not what it used to be, because I took some stuff out, put some other stuff in from what I had previously. So these are the formulas that are going to be given to you on test number 3. It includes sample size calculation. It includes confidence intervals for proportion, mean, standard deviation. And it does hypothesis testing for proportion, mean, standard deviation. Okay. Along with that, you do have the that thing that I handed out to you, which I need to post, but I'll get that here. Regarding the steps for hypothesis testing, that will also be given to you on the test. Okay, there we are. This thing right here. So let's download that PDF. We will go out and post that to the notes. File. Steps for hypothesis testing. There we go. Yes. So hopefully that information will help you as you prepare for the exam. So any question about the schedule or anything like that right now? Okay, so what I want to do today is I want to start by doing a sample size problem after I do something else. Okay. That's right. So it's not really starting. Sorry. So what we're going to talk about is a very general topic, and this is how to study. There are certain numbers of people who have come to me for help, and they have found that they did not know what is the first question you should always ask yourself when confronting a problem. First question that you should ask for is, what kind of problem is it? If you start to do a problem by trying to calculate something, that's wrong. You should not do that. You should not look at a math problem and begin by calculating. That's the wrong thing to do. You should not do that. The first thing you should do when confronting really any problem is find out what kind of problem is it. This works in relationships too, by the way. If somebody comes up to you and they say, hey, you didn't wash the dishes, that's probably not the problem. The problem is something else. And the not doing the dishes is a symptom of that problem. A lack of agreement on household tasks. A certain amount of scheduling that needs to be fixed or something like that. Problem generally is not the thing that first presents itself. So you have to ask the question, what kind of a problem are we talking about? Same thing is true with statistics. There are 3 kinds of hypothesis tests. There are 3 kinds of confidence interval tests, and there's a sample size question. If you try to use confidence intervals on a hypothesis testing problem, it's completely wrong. It doesn't matter how good you are calculating. If I ask you a question about what are the hypotheses for something, and you find a critical value, it's completely wrong. If I say, what's the test value, and you tell me the hypotheses, that's completely wrong. So you actually have to know what kind of a problem is it before you do anything else. That's the first thing to do for any problem that you're given. Now, when we're doing that here, in our situation, we have 2 general types. We have the confidence interval problem, and we have the hypothesis testing problems. If you can't tell by reading a problem which kind of problem it is, that's a problem. So most of the time when you see the word confidence interval, that means it's a confidence interval problem. If you don't, it's a hypothesis testing problem. Okay? Now, there are 3 kinds of things under each one of these. We're doing proportion, mean, or standard deviation. If the question does not have anything with mean or standard deviation, then it's a proportion problem. Okay. Once again, I got to emphasize this as much as I possibly can. If you don't know the difference between these things, then you're not going to be able to be successful. Now, most of you, all right, have enough practice in this process that you don't have to do it by writing this thing down. You already know that this is what you're supposed to do. You already know that you need to figure out what kind of problem it is. You already have this in your mind. I need to know which kind of the 3 things it is. Some of you have not done this in the past. You don't understand the logic of how to take a test. You think that taking a test is sitting down and doing something, but it's not. First of all, taking a test is thinking about something, figuring it out, and then the doing comes after you think about it. So the doing is secondary to the thinking. You have to decide what kind of problem it is before you do the problem. That has to come first. Okay. Now, once we establish that, okay, then there are various things that need to happen for hypothesis testing or for confidence intervals. But a big deal is what do the symbols mean and what numbers to use? A lot of people have trouble with the concept of n. And it appears in most of the formulas that we have. If you take the number, which is supposed to be n, and you put it in for the standard deviation or for the mean, then the problem is going to be completely wrong, and you're not going to be able to get the right answer. You have to be able to read through a problem and know what n is right away. But you can't do that if you don't know the meaning of this letter n. What's the meaning of the letter n? Donna?
A number?
No. When you say the number, there are probably 6 numbers in a problem. So it's not just the number. You need to have a very much more specific idea of what n is. The number of what?
People surveyed.
The number of people surveyed or the number of data values. Okay? Now, Donna, was that in your mind?
Yes.
Okay, but it didn't come out your mouth. Yeah, that's right. So when you're on the test, you'll be okay because you knew that. All right. But that's what n is. The number of items, the number of people surveyed. And again, I'm saying this to you, but most of you know this. Some of you don't. That's why I'm putting it up here. Okay? And then everything else in the problem. Where is the mean? Where is the standard deviation? Where is the proportion? You need to practice doing that so that you can look through a problem and you say, okay, here's a number. I know what that means. I know what symbol it goes with, and I know what formula it goes into. Practice allows you to be able to do that. I'm pretty comfortable with the fact that most of you know how to do it, but if you don't, you've got to do that. You've got to go through and practice, not computing, not putting things into your calculator. You can't start there. You have to be able to identify the number and put them into the right formula in the right place. And then you do the computing, and it happens. Now, number 3 thing that you need to know are the procedures. Okay, not just here are numbers and here is a formula, but when do you use a formula versus other things? This includes critical values, which come from the table. This includes understanding what alpha is. If it's a confidence interval, then we need to know alpha divided by 2. If it is a hypothesis test, we just use alpha most of the time. Not going to have 2-tailed tests on this test. You need to know that for the test value, you use a formula. You need to understand how to construct or how to make H0 and H1. You need to know your decision rule. And you need to know what reject the null hypothesis actually means. Most people really struggle with the word reject. They think that reject means that you don't want it. And that's correct, but rejecting the null hypothesis is what we want to do. Because if we reject the null, that means there is evidence for the alternative. And this is good. This is what we want. But people often say reject it, and they don't know what that means. Reject the null hypothesis means we are doing what we want, which is to prove the alternative. People think rejecting is bad, but it's not. Rejecting the null hypothesis is what we want to do because that proves the alternative. If we do not reject the null hypothesis, there is not or not enough evidence prove the alternative, which means there's no decision. Pretty much that's a bad thing, okay? We're not able to make a decision. We cannot prove something. So if I do not reject the null hypothesis, then I'm kind of stuck. There's nothing I can prove at that point. Now the reason why we say it this way is because hypothesis testing is all about proving a difference. And proving a difference is all about the alternative hypothesis. We're trying to prove the alternative hypothesis. That's what we want to do. In order to prove the alternative, we have to reject the null. That's what we want. So the concept of rejection is a positive thing. We're rejecting the equal sign. We're proving the difference. And that's our goal. As it turns out, there's a thing in the textbook where they talk about the claim. We don't care about the claim because all we really need to do is worry about the alternative hypothesis. Whatever somebody claims in the course of saying a problem is not important to our purpose. So confidence interval, pretty much, we got that going. All right, so that's an overview of what this test is going to be about and how to study for it. It's also an overview of what every test is about and how to study for it. Figure out what kind of problem it is. You have some options. You have to decide that first. Figure out if you have some kind of formulas, what the symbols mean and how they're related to the numbers that are in the problem. And then based on that, to know what to do with those things. And in this particular test, calculation is not everything. Knowing the procedures does not always mean putting numbers into your calculator. So you need to be aware of how to do those different kinds of parts of hypothesis testing. All right. So with all that in mind, let's do a sample-sized problem. So if I have a previous survey where 90% of people have access to produce, and I want to be accurate within 2% for a 99% confidence interval. What sample size do you want? I'll give you 3 minutes, see if you can come up with this here.
We use table E to find the Z for 99%.
Probably not the best option. Probably better to use table F.
Oh, when we first learned Z, right?
Correct? All right, check with your neighbors. See if your neighbors got good stuff going on.
Oh, that's great. So like, I won't say more than but that's like smart. And you change that into like a like 2%. Right. Yeah. Yeah. And so that's why. Okay, that's why I got like. If you were to then you want to be within it. Do you need to copy You were like, I don't know that way. I don't know. It's probably the two. So yeah, we got the same number.
And then you just go to 0.00.
When it comes to people, if there's a decimal, you go to the number off above it.
If you're using table F, you don't have to worry about that.
The final answer.
Oh, the final answer, I'm sorry.
Yeah.
Okay, I thought you were talking about this.
No, I have all that other stuff done.
Doesn't matter.
Okay, fine.
Whenever we're calculating sample size, the answer doesn't really matter a whole lot. It's just a ballpark. Okay?
You accept the items or not?
I would. Natasha, what'd you get for an answer? Oh, well, that's not what I got. What'd you use for Z? But it's a 99% confidence interval. Oh, wait a minute. That's what I've got here too. It's crazy. Oh, ho, ho. Yeah. I used the wrong number. So yours is looking better now. Oh, What? 20.
No, on the test book we had, let's say that one, it says that it's been rounded 2.58 in the textbook. I didn't round it, I just used the 2.576. Which way would you want to do it on the test?
It doesn't matter.
It's still be about the same.
It would be. I'm sorry, what was the number you got? The answer? 1,493. Yep, I got you. It is relatively important for you to understand what you're actually getting here. 1,493. What you're getting is a recommended sample size that you're going to do in order to come up with a confidence interval that has a certain amount of accuracy. But the fact of the matter is, when you actually go out and do your survey, it's not going to necessarily be a 90%. And so therefore, it would not have the exact number of 1,493 that you would need to use. So you're just getting an idea from a calculation of sample size, ballpark, how many people do you need? And it's not like you're going to survey 1,493 people and then stop because you don't need that 1,494th person. That's not what it's about. It's just giving you a ballpark idea of how many people you would have to survey in order to be a certain amount of accuracy. So if you stop with 100 people, that's not enough. If you do 1,000 people, that's probably still not enough. If you do 1,500, that's probably good enough. Okay. And for whatever reason, every single time I do this problem in class, somebody asks me how accurate it needs to be. Even after I say the first and second and third time, this is a ballpark number and it doesn't need to be accurate. And the good thing is we're not going to do this anymore after this test. So then I won't have to answer that question anymore. So that's good. All right, so that's sample size calculation. Any more questions about sample size calculation? Okay, so now we need to do hypothesis testing. We haven't done yet. In our review. So let's say that we've got sure, let's do sodium levels. Sodium levels. All right. And let's say that I've got a national number of 3,000. And I asked Western students, and they say 2,500. These are averages. And standard deviation of 400. And I measured, this was a survey of 25 students.
And you said this is confidence interval?
No, this is not. Is
I didn't listen.
the Western average less than How do I know this is not a confidence interval problem? It doesn't use the words confidence interval. All right. So this is not a confidence interval problem because it doesn't say confidence interval. So it's a hypothesis testing problem.
So do we know what's the standard deviation? About this, like, because they gave us a standard deviation?
When we're asking the question, what kind of problem it is, we don't just look for the information that's given to us in the problem. We look for what they're asking us about.
So average would be the mean then
Yes,
on the problem.
yes. Oh, I made a mistake. Standard deviation is 14. And we're going to use alpha equals 0.10.
I don't know why.
All right, so you're checking with your neighbors hopefully to find out what they've got going on.
If it's greater. It's right, if it's greater, you subtract. Yeah, but that's totally yes.
All right, Danielle Koch, what's our first step here for hypothesis testing?
To and the null.
Oh, I guess.
Okay, so what do you got for me there?
The null hypothesis equals 2,500. The alternative mu is less than.
3,000. Okay, we're comparing it to the national number. This is our sample number. 2,500 is the average from the sample. So that's not what goes in there. 3,000 is what goes in here. And we know that again because of the way that it's said, is the Western average less than the national, then that would mean mu less than 3,000. The statement of the problem is going to be the alternative hypothesis. And we're not just talking about the sample being less than 3,000. We're talking about all Western students. Okay? We took a sample of 25. We know that that's less than 3,000. But the question is the average of all Western students less than 3,000? So that's why we have mu up there. Okay, Danielle, does that make sense?
Yeah.
Okay. All right, Casey, what's next? Okay, where are we going to look for that? Okay. Okay, so we're looking at table F. We have 24 degrees of freedom. We have our alpha of 0.10. And so I want to draw a picture here. But first, Casey, I'm sorry, what's the number that you see on the table?
Oh, 1.318.
1.318, okay? So since we have an alpha of 0.10, degrees of freedom is equal to 24, then the number we have on the table is 1.318. But we actually need to draw a picture in order to see what that looks like. So Jackie, tell me what that's going to look like. If that counts.
We have 0 in the middle, and then we have our critical value over on the right side. At 1.318. Oh, less than. Oh, nope, we're going left.
Okay, so we're going to the left side because it's less than. So that means we're over here. So what is that number, Jackie? It's,
Negative 1.318?
yes, negative 1.318. The left-tailed test, t-scores and z-scores are negative on the left-hand side. So then our rejection region is to the left of that number. Okay. Emily in the back, can you tell me what's the next thing for hypothesis testing? Find the test value. Did you get a number for the test value? Okay, so then if we'd round that off, negative 1.786. would work for us here. Which is x bar minus mu over s over square root of n. It's important that you have the correct value in for the different types of average. This would be 2,500 minus 3,000, so you get a negative number there. All right. So, Alyssa Peterson, what happens next? Or do you have a question?
Oh, I have a question. How did you get negative 1.318?
Because we're using a one-tailed test. Hypothesis tests are always one-tailed.
Right.
So we look at one tail, and we've got an alpha of 0.10.
Okay.
And then we have degrees of freedom of 24. Since we have 25 students, that's where we get that number.
All right, that makes. You don't have to do that alpha divided by 2 thing.
No, we do that for confidence intervals, but we don't do that for hypothesis testing. Confidence intervals are two-tailed. Hypothesis tests are not. At least they're not when I give them.
All right, thank you.
Sure. All right, Natasha, can you tell me what happens next?
I said the test value was in the rejection region, so reject the null hypothesis because there isn't evidence to prove the alternative.
That's correct. We reject the null hypothesis, and that tells us there is evidence to prove the alternative. Okay, because the test value is in the rejection region. Okay, so we have proven the alternative. So, Emily Grenier, can you tell me what that would be as far as the long summary?
With 90% confidence, there is enough evidence that supports that the population mean of sodium levels is less than.
Whoa, sorry.
Sorry.
With 90% confidence, there is evidence that the population mean of sodium levels, and what comes after that?
Is that okay? At Western
At Western
is less than the national.
is less than national.
Parts of the conclusion are gonna give them.
Yes. Okay. So we did our survey, we came up with 2,500 as an average, we came up with 1,400 as a standard deviation. Now there's a lot of variation in our data, okay? Our data is spread out quite a bit. But because we're taking a sample of 25 students, we know that samples, as they get larger, they make our numbers more accurate. So this sample is large enough to create more accuracy for our number, so that the 2,500, we can actually say it represents something which is lower than 3,000. If we were to ask the question, what is the actual sodium level average for Western students, we would use a confidence interval for that, which would come out to be somewhere between 2,000 and 3,000. So it is less than, it's not a huge amount less than, but we can at least say it's less than this national number. Okay, so that was hypothesis testing for the mean. Question?
What was the formula that you used to test value? I used the wrong one. Okay.
Another question, Brandon.
How do you know that it's 90% confidence?
Because this was an alpha of 0.10.
Okay, that's what I thought.
With hypothesis testing, we just take 1 minus this number. Okay. All right, so now we're going to do a different problem. We're going to change this to say the national standard deviation is 1,000. Is the Western standard deviation more than the national? And we'll use alpha 0.05.
Use table G for that, and also for.
We do? That's weird. Well, it's not completely weird.
What is the difference between us and small signal in this switch? I don't know.
Okay,
It's the sample standard deviation. And then the other one was the national.
Which ones, you know, that information, do we?
Yeah, we do. It's national is 1,000 and then a sample would be 1,400.
Sample is us.
Yep.
So you're saying that would be right?
1,400, yeah. It says Western students and then 1,400 standard deviation.
I'm gonna say the difference between population.
okay, Natasha,
Yeah.
when we ask the question, what numbers here came from the sample? How do you answer that question?
I don't know, that's why I'm struggling.
Okay? If I look at this number, which says national standard deviation is 1,000. This says Western students, survey of 25 students. This is the average, this is the standard deviation.
Sample standard.
So.
Why?
Because 1,400 is from the survey.
Is that the sample?
Yeah.
So this is the sample number. That's how I know it's the sample number.
I think it's hard because on my paper I have a
Oh,
written
yeah.
from number 2 and then number 3. Those all up there, but I didn't write it.
So the sample is 1,400.
Okay,
Yeah, okay. Otherwise, we have the same. Yeah. Everything else is the same.
so Natasha, what I would recommend is you don't do that on the test.
I assume you'll have each number written out. So it won't be like, oh, we're gonna need information from that one, but change it to this.
Yes, that's correct.
Oh, that's-
But it was also the same in the previous. But anyway, here we go.
You're talking on the top.
Yeah.
That's-
Okay. No, because we're on the side.
Yeah, yes, and this is step 2. So you go to.
Oh, this is our critical value.
Yeah, this is our critical value. Yeah, see, that's what I keep missing too. But I didn't remember this time, right?
I don't know. That girl, I always said it.
All right. Danielle in the front, tell me what's my first step here.
To state the hypothesis.
Okay, so what do I have?
Standard deviation equals 1,000 for your null hypothesis.
Okay,
And then the alternative hypothesis is sigma greater than 1,000.
Okay, so this is hypothesis testing for the standard deviation. So that means we're going to be using sigma. Amanda, can you tell me the next thing we need?
We're gonna find the critical value.
Okay, so where are we going to go for that?
We are gonna go table G,
All right, we're on table G.
and then we're gonna round it for and over the 0 times 5.
Okay, what's that number?
36.4.
36.415 is that number. Okay, that's a critical value. It's good for us to actually draw that picture then. Eric, can you tell me what that picture looks like?
Right field,
Okay,
and our critical value is 36.415, and we're looking at the area to the right.
okay, where's my 0?
That's in the corner.
Okay, 0 is over here. This is a right tail test. This is 36.415. Okay, Emily.
On the test, are we gonna have to draw the picture?
No.
Okay, thank you.
I recommend that you draw the picture. But no, you don't have to. Especially when I ask you what is the rejection region, you would have to state in words what the rejection region was, or you can draw the picture.
It's the rejection region is greater than 36.4.
You would need to say chi-squared greater than 36.
Okay, cool.
Okay. All right. Humphrey, what's next? Okay, did you get a number for that? Ooh, we need a formula for that. Humphrey, can you tell me what formula I need for test value? Chi-squared. And then what? Minus 1 in parentheses. And then s squared on the top and sigma squared on the bottom?
Yeah.
All right. So, Emily Grenier, you got a number?
47.4.
47.04. As I mentioned, it's really important that you understand which one is the sample number. The sample number comes from the sample. So then it's the 1400. That's the number that's used for S. The population number is the other standard deviation in the problem, which is 1,000. That's sigma. And when we look at the null alternative hypothesis, that's also sigma. So we know what sigma is, 1,000. And we know what S is, 1,400. Question?
So would it be safe to say that if you're looking for like if you're trying to find ways to recognize differences
Right.
between proportion mean and standard deviation problems, would it be safe to say that with the standard deviation for hypothesis testing, there's going to be 2 standard deviations, where in the mean there's only going to be 1?
Yes.
Okay.
Okay. So, Donna, what happens next? Now that we have our test value of 47.04.
We need to make the decision to reject or not reject.
Okay, so what do we do here then, Donna? Okay, so we need to know how to decide our decision. Michaela, can you tell me how to decide our decision?
The number is in the shaded area, you reject it.
Reject what? The null hypothesis. Okay. Is it in the shaded area?
Yes.
Okay, so then we reject the null hypothesis. Okay? Donna, does that make sense?
Yes.
Okay. Do I reject the null hypothesis? Haley, can you tell me what that means if I reject the null hypothesis?
Alternative hypothesis.
Okay, that's correct. There is enough evidence to prove the alternative. Okay. So then, with 95% confidence, there is evidence that the population's standard deviation of sodium levels of Western is more than natural. Okay. All right, so it's time for us to take a break. So that would be 4:17. But we've actually gone through everything, haven't we? All the different parts, the different stuff. So what we're going to do is we're going to take 5 minutes. And I'm going to talk about something and then we can be all done.
Oh, wait, never mind. Can I show you something?
Sure.
Just so that I stop confusing myself. This one we didn't do, right? That formula?
You are correct.
Okay, because I was looking at this one and I was like, wait,
Mm-hmm. Yep.
that one doesn't look right.
Yep. So this is,
Yes. The previous survey. Yeah, I was watching
You're probably not.
So,
the rest of the.
Oh, did you? Yes. So yeah, I couldn't think of these guys asking. Well, and I was confused too because every other time I do this one, there's numbers total, and like, you know what I mean, it's not just percentages. Because like that's everything I had.
We use GitHub, like the flowers, like the alpha, 0.5, the 99% confidence.
oh,
Or we have to.
okay, I will tell you this, and then when you come over here,
We'll
you'll.
have to figure that out. That's exactly what I was confused too. I think it's 90% because they're saying, because the question is what size do I need? So you need to find out how many people would need to be combined with these numbers. So obviously your total's gonna be 100. So that makes sense. Yeah. Right. So then we have to be 90%. Well, PHAP is 90%.
So.
That's, this one I was wondering.
Did you see that?
Oh, right, okay, because PHAP comes from organic. So then PHAP and then QHAP, the QHAP is 1. Right. So then you get the 0.1.
Okay, I have that.
Yeah, so it was 90. Or no. Yeah. 2.5. Yeah. E was I know that I wrote these equations.
It doesn't. I know it's the point two, but I can be accurate with it. So that's like the. I wonder if that's supposed to be.
Oh, yeah.
Like so higher and be less accurate.
I was
It's like the percentage that you want to use with.
Okay, so let's do.
Like that's why I like you. Eric's like.
It's unfair.
Right, yeah, but then E is like.
Why was P not 90%? Usually it's the actual percentage.
Yeah, but it was like given. I just think. So it's already there. It's not given, you're given 20 out of it.
Are we talking about the stuff that you understand the test?
Yes.
So that's why I'm thinking what's
Yeah.
Yeah.
I don't need to know it. Do I need to know that?
Kind of, but not really. How about that?
I totally forgot we learned about this, so.
P-value is the one that
Okay, so where is
Right,
it?
because it was the example
There
of
it
house thing. Yeah. That's how it was with my P-value notes.
Oh, yeah, it's like one thing.
P-value is like this much. Yeah, same. I literally had a picture and then that's it. And then step one and step two, and then all the rest of my notes came from like the homework.
Oh, yeah.
I was like, that's what I started out. Do you still rewrite your notes? Right. There's one like all first and yeah, I'm like, oh, rewrite this. Okay, yeah.
But like, I really, I forgot that it's.
Right, towards it.
I used to do it for every class too, like, I would sit and I would just.
So you get the co-op
See, I do it like this, I like to take it all. Things that I need to know.
Okay, further, support that right now. I did one whole book, finished that.
You're like this, you say.
Oh, I erased my time frame. Okay, so we're gonna start back up again.
I just remember your bio.
All right, so what's gonna happen right now is I'm gonna be talking about stuff, but it's not gonna be on the test.
Why would you do that?
Because what's going to happen after the test is we're going to be talking about some situations where this thing does come up, but then we're going to say we're not going to do it. Okay? And so I'm going to explain to you where we're going and the step that we're skipping. Okay? So right now we've talked about confidence intervals and hypothesis testing for the proportion for the mean and the standard deviation, okay? And I'll give you a minute if you want to write this down, because then we're going to expand on this just a bit, okay? And once again, the reason why I'm doing this is because it's going to come up later, and it's reasonable for us to talk about it now while you're still thinking about it. Okay. So, in this situation, when we talk about hypothesis testing, we always say it's trying to do what? It's trying to prove a difference. Okay? And what do confidence intervals do? Nope. It uses a sample to measure a population. By the way, that question is going to be on the exam. What's the purpose of the confidence interval? It uses a sample to measure something about a population. Okay. What we have been looking at currently for the proportion, the mean, and the standard deviation specifically is one population compared to a number. So we will say something like, the national survey says this, we're comparing Western students to that number, which is from some kind of a national survey, okay? We assume that that national survey number is the number to compare to, okay? And so we're taking our group, Western students or Minnesota residents or whatever, and we're comparing it to some big number that's out there. However, another thing that's very common is that we would be comparing two groups. So instead of taking our group, our Western students, and comparing it to some national number, we would do something like compare, let's do some examples. The weight of let's say preterm babies, the whole. Or we would compare the percent success of nursing versus human services. Or we could compare the standard deviation of the staff in the spring versus the fall. Okay, so what's happening is that we're measuring two different groups and we're trying to figure out if there's a difference between the two of them. Okay, instead of going through and saying there's some national number that we say it's accurate, we're saying there's two groups and both of them have variation, right? So then what's that actually look like? Well, I've got different colors. I'll use different colors. So let's say that I have a p hat for this group. And I have another p hat for this group. Okay. So there's sample variation between them, right? Like the percent success of a particular program. And you say, well, depends on my sample. Sometimes it'll be higher, sometimes it'll be lower. But can I say there's an actual difference in the proportion between the nursing students versus the human services or whatever? How would I go about doing that? Well, I would again have the same process as I had before. I have null hypothesis, test value, critical value, everything like that, right? So then I would be going through that process with those things. Now, if you just happen to look at the resources section and you are dealing with the formulas and tables, and you said, okay, well, here's my confidence intervals, pretty complicated. Here's my hypothesis testing. Well, when you start looking at this stuff, when we're doing the difference between two averages like this, and the difference between two proportions, okay, this is the formula that you need to use to find the difference between two proportions. So it's really complicated. It takes a lot of work. There's a lot that has to happen there. The nice thing is, we're not going to do it. Okay?
So is this like a two-tailed test?
Well, no, it can be one-tailed if we know that one of them is definitely over here and the other one's over here.
Oh, okay.
Then we can make it be one-tailed. Now, it's true that we can do this for proportions, we can do it for means and for standard deviations. However, what's going to happen after the test, after test number 3, is that we're going to be talking about two variables, which means we're going to have x and y. Currently, all we have is just one thing that we ask. What's your sodium level? After the test, we're going to be talking about two variables, x and y. And then our last topic for the term is going to be multiple samples. So we're going to have a P1, P2, a P3, and a mu1, mu2. We're not going to do standard deviations, but. So then what's going to happen at the end of our term is that we're going to be talking about, let's say I measure not just people from Wisconsin and Illinois. Let's say I do Wisconsin, Illinois, Michigan, Iowa, Indiana. And I want to compare all those proportions to each other or all those averages to each other. Then I'm going to have to do some work once I get to there. And then this, comparing two groups, this thing had those really complicated equations. This thing is going to be a different kind of process. So we have the one kind of thing comparing to a single number. We're going to skip this one where we compare two groups. And then later on, we're going to have here where we have 3 or 4 or 5 different groups. That's going to come later. So I wanted you to know what we're missing, because when we get here, then we're going to be talking about that. All right, that's good enough for me.
I have a question.
We'll call it then. Yes.
On the notes somewhere, do you have the definitions of what, like, for example, you said we'll need a definition of or why? Does it just go to that you'll ask for?
I'm not going to ask those definitions.
Okay.
You're not going to need to know the second one. Hypothesis testing, you don't need to know that. The first one you do, confidence. You need to know that.
So like what the point of one is?
The purpose of the confidence interval is to use samples to measure population.
Is that the only one?
That's the only definition. Yep.
Know that, right? So
Know that definition, yes.
Rick.